This is the one before the last chapter. This is chapter 5. Applications of integration. We're only going to look at 5.1 and 5.7. In 5.1, we're looking at consumer and producer surplus. Let's look at the idea here. We're given two functions, d of x, which is price, at which consumers are willing to pay for x units. And it is a decreasing function. Say something like this. That's the d of x. Now we're also given s of x, which is the price, same thing, but for producers are willing to produce or sell x units. And of course that is an increasing function. Let's say it's this function. This particular point where they intersect, this point, is called the equilibrium point, where everybody's happy. Now, there are two areas that we are interested in. We're interested in determining this area, which is consumer surplus. And we are interested in determining this area, which represents producer surplus. Very easy to remember how to determine this. So this is a rectangle, and will be used in determining the consumer surplus and the producer surplus. No need to memorize these formulas. So how do I determine the consumer surplus? Consumer surplus is the integral. I'm going to put a number here, or just xe, the x of the equilibrium point, and this is ye, the y of the equilibrium point. So this point is xe, comma, ye. Let's call it E, equilibrium point. So from 0 to xe, from the consumer, from the dx function times dx times dx, minus the area of the rectangle, which is xe times ye. This will be the consumer surplus. How come? This area is the integral under the graph of d of x from here till here, everything, from which I have to subtract the area of the rectangle. The area of this rectangle is xe times ye. Now, how do I determine the producer surplus? It's the other way around. Why? Because I want to determine this area now from the area of the rectangle. I subtract the area under the graph of Sx from 0 to xe, Sx dx. So to determine the top, from the whole thing I subtract the rectangle, the area of the rectangle. To determine the producer surplus, which is this area, from the area of the rectangle I subtract the area under the graph of S of x. So these are the two formulas needed in this chapter. Forgive me, in this section. So let's look at a couple of examples and see how we determine those areas and how we determine the equilibrium point, which is basically algebra. Okay, so this is going to be my page 2. So let's start with, let's say, problem 5 on page 479. We are given d of x, the price at which consumers are willing to pay as a function, and we are given s of x, which is x squared, which is the price at which the producers are willing to sell. In part A, we're asked to find the equilibrium point. The equilibrium point is determined when those two functions are equal to each other. X minus 6 squared equals x squared. I square the left-hand side, and I get x squared minus 12x plus 36 equals x squared. I subtract x squared from both sides, and I get x equals 3 units. Now let's see the price. When I plug it in here, I get 3, 9. So the equilibrium point is 3, 9. The area of the rectangle is 3 times 9, which is 27. So in order to determine the consumer surplus, I will have to find the integral from 0 to 3 from d of x dx minus the area of the rectangle. To find the producer surplus, which is part B and part C, I will have the other way around, 27 minus the integral from 0 to 3, of course, dx, from x squared dx. So let's determine those two integrals. So for the consumer surplus, the integral from 0 to 3 from x squared minus 12x plus 36 dx minus 27. This is x cubed over 3 minus 12x squared over 2 plus 36x from 0 to 3 and minus 27. When I replace x by 3, I get 27 over 3, which is 9 minus 54 and plus 36 times 3 and minus 27. And when I put all this in my calculator, I get 9 minus 54 plus 36, okay, $36. Now I have to determine the producer surplus, which will be 27 minus the integral from 0 to 3 from x squared dx. So 27 minus x cubed over 3 from 0 to 3. So this will be 27 minus 9, which is $18. I think we should look at another example before moving on to the last section of this chapter, which is 5.7. Let's say, let's look at problem 11 on page 479. With the d of x equals 100 over the square root of x, and s of x equals the square root of x. All three questions are the same. So first I have to determine the equilibrium point where d of x equals s of x, which means 100 over the square root of x equals the square root of x, cross multiply. So I get x equals 100. So the equilibrium point has 100 comma. When I replace 100 in any of them, I get 10. So the area of the rectangle, is x times y of the equilibrium point. So it's 1,000. So in part B, the consumer surplus, as we know, is the area under d of x from 0 to 100, from 100 times x to negative 1/2 dx minus 1,000. So this will be 100. X to negative 1/2 plus 1 is x to 1/2 over 1/2 from 0 to 100 and minus 1,000. So I multiply, I have to flip 1/2, so this is 200. And this is the square root of 100, which is 10, minus 1,000. 2,000 minus 1,000 is $1,000. In part C, the producer surplus is the other way around, is 1,000 minus the integral from 0 to 100, but this time from the other function, which is x to 1/2 dx. So 1,000 minus x to 1/2 plus 1, 3/2 over 3/2 from 0 to 100. 1,000 minus 2/3 times the square root of 100, which is 10 cubed, is 1,000. So 1,000 minus, so it's 1/3. 1 minus 2/3 is 1/3. 1,000 divided by $3. I think this should be giving us the idea of this section, and you will not be responsible for anything else. And the last section of this chapter is entitled Differential Equations. What is a differential equation? It's an equation that has derivatives in it of different rank. So 5.7, differential equations. They're not extensive or too difficult. This is just an intro, a basic intro of two differential equations. On page 533, I would like to start with, let's say, problem, why not? Problem 9 on page 533. And we are given that f prime of x equals x to 2/3 minus x. And we are told that f of 1 equals -6. Find the particular solution determined by the given condition. If you remember, f prime of x can be replaced by dy over dx, which makes x to 2/3 minus x. I will cross multiply or multiply both sides by dx. So dy equals x to 2/3 minus x dx. I'm allowed to integrate both sides. And let's see what we get. So the integral from 1 dy is y equals x to 2/3 plus 1, which is 5/3 divided by 5/3 minus x squared over 2 plus a constant c. We'll simplify a little bit by flipping 5/3. So I have y equals 3/5 x to 5/3 minus x squared over 2 plus a constant c. I am told that f of 1 is -6. So -6 equals 1, which is 3/5 minus 1/2 plus a constant c. I will multiply both sides by 10. So -60 equals 6 minus 5 plus 10c, and that's 1. So I have to subtract 1 from both sides, and 10c. c equals -61 over 10. So I have the particular solution, function 3/5 x to 5/3 minus x squared over 2 minus 61 over 10. And that was a problem 9. I'm checking my numbers, -6 3/5. So multiplied by 10. 10 divided by 5 is 2. 10 divided by 2 is 5. Yes. And that's 1. I subtract 1. Yes. Let's move on to now, let's say, problem 13 on the same page, which is page 533. We are given a function which is y equals e to the x plus 3x e to the x. We are asked to show that this is a solution of y double prime minus 2y prime plus y equals 0. I'm checking whether I copied the function correctly, e to the x. Yes, I did. And I copied the equation. Correct. So from here I need to determine first of all y prime, which is e to the x. This is the product rule, plus 3. The first function prime is 1 times e to the x plus x e to the x. And now the second derivative, e to the x plus 3 e to the x plus e to the x plus x e to the x. Now I'm going to replace them in here and see if I get 0. So the second derivative is e to the x plus. E to the x plus e to the x is 2 e to the x multiplied by 3 is 6 e to the x plus 3x e to the x. And I replaced, so far, I replaced this, which is second derivative of y. Now, minus 2 times the first derivative. Minus 2 e to the x minus 6 e to the x minus 6x e to the x. So now I accomplished this. And now plus the function. So plus e to the x plus 3x e to the x. And let's see what we get now. I see an e to the x with an e to the x with a negative 2e to the x. I see 6e to the x with negative 6e to the x. And I see 3x e to the x with 3x e to the x and a minus 6x to the x. And the answer is indeed yes. Y is a solution of the given differential equation. Okay, and now let's look at a few applications and in which we are going to solve. That's for y. So that's my page 5. And let's start. I'm looking at problems 15 through 31 on page 533. And let's start, let's say, with problem 17. In problem 17, we have 3y squared dy over dx equals 8x. Of course, I will multiply both sides by dx, and we get 3y squared dy equals 8x dx. As you see, the variables are separated. Variables are separated. Y is alone on one side, x is alone on the other. Now I'm ready to integrate both sides. The left-hand side will be 3y cubed over 3. There is no need to put a constant here. I'm going to put it on the right-hand side only. Equals 8, x squared over 2 plus a constant c. I will simplify, and I get y to the third equals 4x squared plus c. In order to determine y, I will take the cube root from both sides. And let me write it here. And this is the cube root of 4x squared plus a constant c. And this is the solution of this differential equation. Okay, let's also look at problem 21. We're going to have more examples here. So problem 21 on the same page. Let's see, 21. Okay, dy over dx equals 6 over y. Cross multiply. Y dy equals 6 dx. You see again the variables are separated. I will integrate both sides. The left-hand side is y squared over 2. The right-hand side is 6x plus a constant c. Y squared equals 12x plus 2c. I can denote this by c1. So y squared equals 12x plus c1. I take the square root, and I have plus or minus the square root of 12x plus c1. Okay, let's look at the problems like, let's say, problem 23. In problem 23, we have y prime equals 3x plus xy. First thing I have to do is replace y prime by dy over dx. Secondly, I will have to factor out x. I need to separate the variables. First, I will cross multiply. dy equals x, 3 plus y dx. And now I have to divide both sides by 3 plus y. So dy divided by y plus 3 equals x dx. At this point, the variables are separated. Therefore, I can integrate. The left-hand side is natural log of the absolute value of y plus 3. The right-hand side is x squared over 2 plus a constant c. Now, we know that any logarithmic equation, this is a log equation. For example, log base b of x is y is equivalent to, from the previous chapter, from chapter 4, b raised to y equals x. I'm going to use this very important property right here to solve for y, because this equation is not solved for y just yet. So this is a very important property from the previous chapter. So e raised to this power, e raised to x squared over 2 plus a constant c equals the absolute value of y plus 3. This equation can be rewritten as y plus 3 equals plus or minus. I'm going to break this into two parts. E raised to x squared over 2 multiplied by e raised to c. I'm going to replace e raised to c by a constant that I will denote by c1. So then the equation becomes y equals negative 3 plus or minus c1 e raised to x squared over 2. And this was problem 23. We are told, however, that y equals 5 when x equals 0. So y equals 5 when x equals 0. This will help us determine the constant. So I'm replacing y by 5. Let's see when I replace x by 0. This is 0, e to 0 is 1. So this is negative 3 plus or minus c1. Move 3 to the other side, I get 8 plus or minus c1. c1 is plus or minus 8. Now I can put it back in. So y equals negative 3 plus or minus 8 e raised to x squared over 2. And let's look at problem let's say problem 29. On page 7. My page 7. 29. dp over dt equals 2p. Cross multiply. dp equals 2p dt. Divide both sides by p. dp over p equals 2 dt. And we do have conditions? No, we don't. Okay, very good. We're ready to integrate because the variables are separated. Natural log of the absolute value of p equals 2t plus a constant c. E raised to, so the absolute value of p equals e raised to 2t plus c, or p equals plus or minus e to 2t times e to c, which we will denote by c1. So p equals plus or minus c1 e to 2t. And that was 29. Let's look at a word problem now. Let's say problem 35. On the same page, 533. Total profit from marginal profit. A firm's marginal profit P as a function of its total cost C is given by dP over dC equals negative 200 over C plus 3, everything to 3 halves. Part A, find the profit function P of C if P is $10 when C is 61. Of course, we need to separate the variables again, and I will just multiply both sides by dC. So dP over 1 equals negative 200 over C plus 3 to 3 halves times dC. Variables are separated. If you want, you can put negative 200 here. It doesn't matter. We could. So I can have 1 over 200 dP equals C plus 3 raised to negative 3 halves dC. Variables are separated. We are ready to integrate. The left-hand side, negative 1 over 200p. The right-hand side is, if you remember, we have to let t be C plus 3, dt equals dc. So if you want to use a change of variable, so this will be t raised to negative 3 halves dt. So this is C plus 3. Negative 3 halves plus 1 is negative 1 half over negative 1 half plus a constant C. I'm going to call it C1 so it's not confused with this C. So, or maybe I should call it D. So any other letter because we have C in the problem. So this is a constant. Now we are told that P is 10 when C is 61. So I'm going to determine D right this moment. So P is 10. So the left-hand side is negative 10 over 200. The right-hand side will be negative 2. I flip this. And C, 61 plus 3 is 64. So 1 divided by 64 and the square root plus D. Let's see what we get for D. And this becomes my page 8. So the left-hand side is, I simplify by 10. So this is negative 1 over 20. The square root of 64 is 8. So this will be negative 2 over 8 plus D. Simplify. So negative 1 over 20 plus 1 over 4 equals D. The least common denominator is indeed 20. So this needs a 5. 5 minus 1 will be 4. 4 over 20. So D equals 1/5. Going back, negative 1 over 200p equals negative 2 C plus 3 to negative 1 half plus 1/5. I need to find P. I'll multiply both sides by negative 200. So 400 over the square root of C plus 3 and minus 40. 200 divided by 5 minus 40. So we got the profit function. At what cost will the firm break even? So in part B, we're asked to find C for P being 0, profit 0. Well, I have to set this equation, set this expression equal to 0. 400 over the square root of C plus 3 minus 40 equals 0. And I move 40 to the other side and multiply both sides by the square root. So I have 10 equals the square root of C plus 3. I square both sides. 100 equals C plus 3. C appears to be 97. So $97 will break even. Okay, so let's find another word problem. Good. So let's look at problem 37, last problem for this chapter. And this is my page 9. We're given the reaction R in pleasure units by a consumer receiving S units of a product in the amount of buy. So we are given dr over ds equals k, which is a constant over s plus 1, where k is a positive constant. Use separation of variables to solve the differential equation. So we are asked to find r. So dr equals k over s plus 1 times ds. Variables are separated. S is on one side, r is on the other. We can integrate. So r, of course, the right-hand side is the integral from 1 is r, and the right-hand side is k natural log of s plus 1 plus a constant c. We're not given any conditions. We're only asked to find r. Rewrite the solution in terms of the initial condition r0 equals 0. So this was part A. And part B, they're telling us that r of 0 is 0. So 0 k natural log of the absolute value of s plus 1. Oops. Plus a constant c. Since s, one more time, s is the number of units of a product, I will consider then s plus 1 being positive, so I can use drop the absolute value and replace the absolute value symbols by parentheses. So when r is 0, 0 plus 1 plus c. Natural log of 1 is 0, 0 times k is 0, so c is 0. So I can say now that r equals k natural log of s plus 1. And explain why the condition r of 0 is reasonable. It is reasonable because there is no, so r was, in our problem, r was the reaction in pleasure. So there is no reaction if there is no unit. So when s is 0, it makes sense that the reaction is 0. Thank you.